Welcome everyone. This is the trial session for business mathematics about matrices and vectors. So we also will discuss a part of Gaussian elimination, and a lot of this material is already material from week 4. So you will some of the material you will see for the first time, but I don't think that's a problem because that will help you for next week to better understand your lectures. All right. So who am I? My name is Mark, and I also studied at the VU. I did economics and business economics. And after my graduation, I started the tutoring organization Sophistès. And in the last 5 years, I gave a lot of sessions. I gave people in business and society, business mathematics, business statistics, and I really like to teach. It really is my passion. And that's, of course, the reason why I started this organization. So this is the table of contents of the summary. And today we will have it about vectors, matrices, and Gaussian elimination. And basically, the vectors is part of week 3, but a lot of the material will be discussed in week 4. So you will see that for the first time, but don't worry about it. I will not assume any prior knowledge. Okay. So about this course, we, of course, teach it now via Zoom, as you are seeing. But the weekly sessions and the crash courses will take place at the VU campus because it's better to have it just at the VU so that I can see you guys, and that always works better. I will nevertheless ask you guys a lot of questions, so I will sometimes call your name, and then you can just unmute yourself and you can answer me. And if you're not answering, I will go to somebody else. Okay. And also feel free to ask your questions as well. You can do it via the chat, but you can also feel free to unmute yourself and just to ask me a question. All right. So let's start with the material. The first thing are vectors. And I always say vectors are just a column with numbers or a row with numbers. For example, here you see a column vector called A is 3, 4. So the numbers 3, 4 are the elements of this vector. And here below you see a row vector, and then you also have the elements 3 and 4 in it. And what you should remember about vectors is that we write them down with a lowercase letter. So not a capital letter like this, but you write down a vector with a lowercase letter. And if you are going to type it on a computer, you make the letter bold. So you're seeing that.
I don't want to fucking write it on a computer, bitch.
Oh. So you see that the vector is with a bold letter. And if you are writing it with the hand, you would just put an arrow above it. So this is how you can write a vector just with your hand, 3, 4. Okay, so I will go to the whiteboard and then I will show you something. You can basically see a vector as an arrow. So, for example, if you have the vector 3, 4, you can basically see it like your x dimension and your y dimension. So we can maybe even draw it. And if you do that, you will get something like this. So here you have vector x, here you have vector y. And then I can make an arrow like this. And then you will see that what this vector is basically saying is that you go 3 steps to the right and 4 steps upwards. That's how you can basically interpret a vector. 3 steps to the right and 4 steps upward. Okay. And now one of the questions that you could ask is, what is the length of this vector? So what is the length of this side of the triangle, basically? Because notice it's just a 90-degree angle, right? And maybe you already learned a theorem in your high school. It's called Pythagoras theorem. So you know that this side has the value 3. This side has the value 4. And you want to know the length of this arrow. And maybe you know it. You could use a squared plus b squared is c squared, right? That's what you learned in high school. So you could do 3 squared plus 4 squared is the c squared, so the length of this number. Well, the 3 squared is 9, the 4 squared is 16, and then we can take that together. Well, 9 and 16, that of course is 25, and then 25 is the c squared. And then you can find the answer. So now you know that the length of that arrow, the c, is the square root of 25, which is 5, right? So this is basically how you can find the length of a two-dimensional arrow. A squared plus b squared is c squared. So then the general formula for the length would be the square root of a squared plus b squared, right? So this is basically how you can find the length of your two-dimensional vector. But of course, you can also have that you have not 2 dimensions in your vector, not 2 numbers in your vector, but maybe you have 3 or 4 of them. And I'm going to show you what then would be the formula of your vector. Okay, so here we go. So you could also have that it will go as follows. The length of your vector is the square root of the first element squared plus the second element squared all the way up to your nth element squared. So maybe I can even expand this square root a bit. Then you have it like this. So this is the formula, the general formula to calculate the length of a vector. So remember those 2 lines that you're seeing here? Those 2 lines mean the length of vector A. So what you're seeing here is the length of vector A. So in this case, it would just be 3 squared plus 4 squared, and then the square root of that. So it will be 25 if you fill this into your calculator. That's the length of this vector, but you can also use it when you have 3, 4, or 5 numbers. Okay. Are there any questions so far about the formula? No questions? Okay. Okay, then I will show you an axiom question. So here, by the way, you also see the example we just did. 3, 4, and then you can figure out that the length is 5 with this formula. Okay, so here's an axiom question. I will just give you guys some time. And what I would suggest is that you first write down the formula of the length of the vector. So write down the formula for the length of vector x and see what you can fill in. And then if you eventually know the answer, you can type it via the chat with a direct message to me. So you can just type the answer in the chat if you know it, and then you can send it to me. Okay. I already see one answer coming in. Take into account that you might have 2 answers. That's the hint I give you. So to the persons that already gave me the answer, it might be the case that you have a positive and a negative answer. So just send your answer in the chat if you know it. Yes, very good. I already see a correct answer, but you didn't send it in a private message to me, Monica, but that's fine. Yes, very good, Boris. Okay. No, no worries, no worries. I see some other correct answers coming in. Very good. Okay. I just give you 30 more seconds. Don't feel bad if you didn't have the answer yet. And this is, by the way, how we will work through the material. So I would just give you the theory, the examples, and then we top it off with some action question. And then we work through all the material like this. Yes, I get a question. Do we get the recording after the session? Definitely. So I would just post on YouTube. Then I can make a really nice chapter overview. So then I will state at each time what the topic is I'm discussing. So after the session, you can really easily find everything back. You can just see the titles and then at which minute I discuss a particular topic. So I will post it on YouTube and then you can easily watch it back. Okay. Yes, Saman, it will be indeed +3 or -3. Let me explain. Okay, so the formula for the length of vector x is x1 squared plus x2 squared, etc. But if you only have two numbers in it, it will stop like this. We know that the length of our vector is 5. And we see that this is the formula. So the first number is 4. So 4 squared. And here you get a y. So y squared. So this is what you get if you fill in the numbers from the question. And now you simply need to solve it for the y. So you first want to get rid of this square root. And you can get rid of this square root by simply squaring both sides. So if I square the left side, I will get 25. And if I square the right side, I will end up with 4 squared plus y squared without a square root. Well, the 4 squared is 16 and the y squared is just y squared. So now you have this, you got rid of, you squared both sides. Now I can take this 16 to the other side. So I get 25 minus 16, which is 9. So I get 9 is y squared. And here, a lot of students made a mistake because if to get the 9, you could take y is 3 because 3 squared is 9. But you could also have y is a -3 because a -3 squared also gives me a 9. You see that? So that's what you're seeing here. And to help you a bit, I can also make a drawing. Maybe that helps to visualize it a bit. So what you basically have here, you have your x, and here you have your y. And since x is 4, it means we go 4 steps to the right, right? So it looks a bit like this. And then here you have a 4. And here you have the +3, right? That's what this solution is. So this arrow has a y of 3. 4 steps to the right and 3 steps up. But what does it mean if the y is negative? What does that mean? So if it's positive, we go 3 steps up. But what if the y is negative? Well, then the arrow goes downwards, right? So then it looks like this. So it goes 4 steps to the right, but now it goes a -3 steps in the vertical direction. So it goes 3 steps downwards. That's what you're seeing here. And both arrows have the length 5. And that's what you're seeing here. So you have two possibilities to get a length of 5. You can go 3 steps up or 3 steps down. It all has a length of 5. Are there any questions about this action question? Things you don't quite understand? No? Okay. Then I erase this. And also feel free to slow me down if I am too fast with erasing, and I can just get it back. Okay. Then what you will see is that the algebra that you learn on high school for just normal numbers, it will not apply always for vectors or matrices. So you basically need to relearn algebra all over again now. So I will start with the basics, and you will see that addition is really simple. So for example, if I have vector 1, 2 plus vector 2, 4, it will give me a new vector, and I can simply add those two numbers to get 3. I can add those two numbers to get 6. So if you add two vectors with each other, it's pretty intuitive. You just get a new vector. But take into account that you can only add vectors if the number of elements is the same. So if one vector has 3 elements, the other vector only has 2 elements, you cannot add them. So the only requirement for this is that they have the same amount of elements. Then how to multiply it with a constant. I think that one is also really intuitive. For example, if you have 2 times vector 1, 2, you do 2 times 1 is 2. 2 times 2 is 4. So I also think that one is pretty intuitive, right? So if you multiply it with a constant, you basically are just scaling up your vector. This is called a scalar. Okay. But what's really counterintuitive is the inner product. So you're basically multiplying a vector here. And how will that work? Well, the strange thing is that if you take the inner product, which can be denoted like A times B or open bracket A comma B, you can also write it down like that. That's called the inner product of two vectors. It works as follows. If you take the inner product, you don't get a new vector out of it. You will simply get a number out of it. And that's what's really strange from vectors, that if you multiply them or take the inner product, you get a number and not a new vector. And it goes like this. You do 1 times 2, which is 2. And then you do 2 times 4, which is 8. And then you add that together. So this gives the outcome 10. That's really strange, right? So you multiply two vectors with each other, and you get a number out of it, not a vector. And because that's the case, because it works like this, your property that you normally have doesn't work anymore. So here those are the properties that are still working, like you were used in high school. But this property, it's called the associative property. You don't have to remember that name. That property doesn't work anymore. So what it basically tells you is that if you first multiply B with C and that outcome with A, you get a different outcome than when you first are doing A times B. That gives you a number, right? And then you multiply that number with C. It doesn't work anymore. So basically, your algebra has changed a bit with vectors. But I don't think this is really important. Okay, so I think that's what you should remember with vectors. How to calculate the length of a vector, how to add them together, how to multiply them with a constant, and how to multiply them with each other. And remember, multiplying vectors with each other gives you a number and not a vector. Okay. So now the next topic is the matrices. What is a matrices? Well, we said that a vector is just a row or a column with numbers, right? A matrix is just a table with numbers. So here you see a table with numbers. And for example, the table 1, 2, 3, 4, 5, 6. And how it works is basically as follows. You can sort each element, and this left number is the row. So this tells you row 2, column 1. So row 2, column 1. That's what the 2, 1 tells you. So the first skill that you need to learn is how to know which number corresponds to this element. So for example, if you have this matrix here, you can say row 3, which is this row, and then column 1, which is this column. So that gives me the number 7. You see that? Let's do another one. So here you have row 2, which is this row, and then column 3, which is this column. And that gives me the 6, right? So element row 2, column 3 is the 6, for example. And that's what you are seeing here. Okay. So let's do a game. Let's say that, yes, I have muted them. Thank you, Simon. So let's do a game. Here you have 5, 6, 7, 8, 9, 10. And I want to have the B2, 3. Could you type in the chat what this number is? Which number do I get here? Yes, very good. And then B1, 2. Which number is this? Which number should we have here? You can type it in the chat. Yes, very good, guys. Indeed, a 6. Okay. So that's the first skill, that you can find an element out of your matrix. Okay. So here is a really nice axiom question. I assume that you already know a bit about summations. If not, I can just give you an extra hint. This is an axiom question, and I have to tell you something about the exam. First, it was always like structures like this. You had a closed question where you didn't get any points for your calculation. You just had to give the final answer. And then you had 2 bigger questions where you have open questions. So there you also get points for your calculation. But when the coronavirus spread it, the exams took place online. And then they changed the exams into multiple choice questions. And this is one of the multiple choice questions you had during the corona exams. And I think they also intended to do that for this year, but I'm not quite sure, because for example, EBE, they have this course QRM1, which is the same as business mathematics. So QRM1 is the same as business mathematics. And there they first intended to also do multiple choice, but in the last week they changed it and they decided to make it an open exam. So now I'm not sure anymore. But this is one of the multiple choice exam questions. So if you know the answer, you can just type it in the chat. And after a minute, I will just give you the first hint. So you have to find the value for y in this question. So what is the value for y? And I will give you a hint after a minute. So if you stuck a bit, don't worry about it. We're all here to learn, right? So let me give you guys the first hint. What this summation means, because I did discuss the summation in another video. What they say is that the k will go from 1 to 2 and then all the way up to 3, right? And since it's a summation, we add pluses in between. And then you get x3, 1. x3 2 and x3 3 is 10. So the sum of element 3 1 plus element 3 2 plus element 3 3 equals 10. So maybe you can fill in the numbers for those elements and then you can find the value of y. And if you know the answer, you can type it in the chat. Yes, that's the correct answer. Very good. Very good, Boris. Yes, I always like to put commas in between them, Saman, but it's not necessary. So you can do 3 1, but I always like to do a comma in between so that you know number 3 and number 1, and that you don't think it's 31, for example. But actually the comma is not necessary. You can also write on 3 1. Very good, guys. I see a lot of good answers coming in. I didn't see any incorrect answers so far. It's not E. You can find the value for it. No, the answer is not 3. No. Okay, let me explain it. It's also not F. No. Okay, so let me explain. So if you didn't have it, don't worry about it. So you first had to see that with this summation, they mean element x31, x32 plus x33 should equal 10. That's basically what they wrote down here. Then you have to know that this matrix, this -1 is row 3 and then your first element. Row 3, second element. Let me make some more space. And then row 3, third element. That's basically what they wrote down here. So that those are the 3 numbers that we need. So we know that the x31 is the -1. We know that the x32 is 0. And the x33, that's the y, right? So I have -1 plus 0 plus y is 10. And that means that if I bring this -1 to the right side, I get a y of 11. So the correct answer here is answer D. Y is 11 is the correct answer. Yeah, don't worry about mixing rows and columns. You just have to keep practicing that for yourself. Just look at it every few days. Then eventually it will become really natural that the row is the third row and then the first column, second column, third column. Don't worry about that. Okay, are there any questions about this exam question? No questions? Nothing you find a bit vague that I need to explain over again? No? Okay. Then I'll raise it. See some things in the chat. All right, thank you, Sarah. Okay. Then here in the summary, you can just watch back the solution. Here we go. Okay, the next topic we're going to discuss is the matrix transposition. So let me show you an example. If you are going to transpose a matrix, what you are basically doing is you're transferring the row into a column, and you're transferring the column into a row. So for example, if you first have this matrix, and by the way, a matrix always has an order, and the order of this matrix is that it has 3 rows and 2 columns. So 3 rows and then 2 columns. If you are going to transpose this matrix, you can put a prime here, and then your first row becomes your first column. Your second row becomes your second column. Do you see what happens? Your third row becomes your third column. And that's what happened here. So first row becomes first column, second row becomes second column, and third row becomes third column. And what happens with the order? First we had 3 rows and 2 columns, but now you will see that the order, it flips, right? Yes. So here you now get 3 times 2. 2 times 3, 2 rows and 3 columns. That's what happens if you transpose it. So the order flips. I got an interesting question, by the way. What would be the answer if we have the product notation and not the sum? That's a good question. Let's do that real quick. If that would be the case, then so the question is, what if this one was a summation, not a summation, but a product operator? So what if it would be like this? Well, that could not happen because then those pluses become a time sign. And the problem with that is the following. So if you have a 0 in the times, you can never get a 10 out of it, right? So if this was a product operator, the answer would be no solution, because if you multiply y with 0, there's not a single y you can have to eventually end up with 10, right? Because if you multiply something with 0, you always get 0, no matter what you fill in for y. So if this would be the case, that you have a product operator here, then there would be no solution for y because of the 0 here. Does that make sense? Okay. So let's do another example. If I have the matrix B is 1, 2, 3, 4, 5, 6, 7, 8, 9. Here the order is 3 rows and 3 columns, right? It's a square matrix. If I now take the transpose, what will happen is that the first row becomes my first column. You see that? The second row becomes my second column, and the third row becomes my third column. That's what here the transpose is. And here you still have 3 rows, 3 columns. Okay, so is it clear how to transpose a matrix? Yes, indeed. You keep the diagonal and you flip the numbers. Very good. Okay, so what somebody pointed out very nicely was that the diagonal, those numbers here, those always remain the same if you have a square matrix. That's pretty interesting to point out. Okay. So here, I'm going to show you an interesting matrix. And I will tell you what this is. You sometimes can get a symmetrical matrix. And when is a matrix symmetrical? Well, if you transpose it, then the transpose matrix is the same as the original matrix. So in that case, a matrix is symmetrical. So let me show you. If I have this matrix here and I transpose it, then this first row becomes my first column. This second row here becomes my second column. And this third row here, it becomes my third column. And what you will find is that the transposed matrix is exactly the same as the original matrix we already had. And then you have a symmetrical matrix. So the transposed matrix is the same as the original matrix. Then you have a symmetrical matrix. That's pretty interesting, right? And how can you easily recognize it without transposing the whole thing? I will tell you how. So how you can really easily recognize it is that if you put a mirror here, so let's say that in the diagonal, I put a mirror, so just right here, then you will really see a nice symmetrical. Here you have the 2s, here you have the 4s, I pick another color for that. And here you have the 5s. And you get a perfectly nice symmetry here, right? And in that case, they are symmetrical. So it doesn't matter what's in the diagonal. That doesn't matter. It's all about those numbers. You should have a symmetry with that. Okay. So that's how you can recognize it. You can just simply put a mirror here, 2, 2, 4, 4, 5, 5, then it's symmetrical. That's how you can see it. Okay. Then, like I said, with matrices and vectors, the algebra is completely different than how you learned it on high school with regular numbers. And that means we again have to start all over again to see how simple things like addition and subtraction work. So let me do some examples. And those will be really intuitive and easy, I think, but you just have to see it once. If you are going to add two matrices, you first have to know that you can only add them when they have exactly the same order. So A has order 2 rows, 2 columns, and B also has the order 2 rows and 2 columns. And only if the order is exactly the same, then you're allowed to add it to matrices. If, for example, B would have 3 rows or 3 columns, you could not add them together. So only if the order is the same, we can add them together. And then matrix C will have also a 2 by 2. And then it works really intuitively. You get 1 plus 1 is 2. You get 2 plus 2 is 4. 3 plus 3 is 6. And 4 plus 4 is 8. And that's, I think, really intuitive, right? So always check that the order is the same, else you're not able to add them together. Okay. Then how to multiply a matrix with a constant. I think that one is also really intuitive. If A is a 2 by 2, 2 rows, 2 columns, then B will also have 2 rows and 2 columns, okay? And it works exactly how you would predict it, I think. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 4 is 8. Also pretty intuitive, right? Okay. So multiplying with a constant and addition, I think that really makes sense. But what's really strange with matrices is how you multiply them. I remember when I was in my first year, I saw how they did it for the first time. And I thought it's really strange. So let me just show you some examples, how you multiply matrices and under which conditions you are allowed to multiply matrices. Okay, so I will go to the whiteboard for a second. Okay. So if you want to multiply matrices, you first want to know if you're allowed to do it, because you're not always allowed to multiply matrices, and what the order of that new matrix will be. So I will first show you that. So if you, for example, have this A, which is a 2 times 3 matrix, and B, which is a 3 by 2 matrix, it will work a bit like this. You have 2 rows and you have 3 columns. So this is how matrix A would look like, right? And then you multiply it with a matrix that has 3 rows, so 1, 2, 3, and it has 2 columns. So this is basically what the structure would be if you are going to multiply it. And then you first want to check, are I allowed to multiply the matrices? And you're only allowed to multiply it if the numbers are on the inside are the same. So only if those two numbers that are now underlined are the same, then you are allowed to multiply matrices. If they're not the same, then you cannot multiply them. Then you say it's impossible to multiply them. That's the answer to your question. Impossible. Okay. So now you checked whether it's the same, and here you can now have the insight. Number of columns of the left matrix should be equal to the number of rows of the right matrix, else multiplication is not possible. So a really long sentence, but that's the insight one. So that's the first insight. The number of columns of the left matrix should be equal to the number of rows of the right matrix, else multiplication is not possible. So in one simple sentence, this number needs to be the same as that number, else you cannot multiply. Always check for that. Okay. So now you check that and you see that's fine. We can multiply them. Then you want to ask yourself the question, what will be the new order of my new matrix that I will get out from this? And the left matrix gives the left number. So this is a 2. And therefore I get a 2 here. And since this here is a 2, I will also get a 2 here. So the left matrix determines the left number, and the right matrix determines the right number. That's what you're seeing here. So in words, I will get 2 rows and 2 columns. So a 2 by 2 out of this. And eventually I will do it with the numbers, but this is just the structure. So inside 2, the left matrix determines the number of rows. The right matrix determines the number of columns. Okay, so let me show you another example. Let's say that I have matrix C, or let's make it matrix D. And matrix D is a 3 times 3 matrix. So it looks a bit like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 rows, 3 columns. A matrix E is a 3 times 2 matrix. My first question, am I allowed to multiply those with each other? Am I allowed to do that? And the answer would be yes, because those two numbers are the same, right? The numbers on the inside are the same. Very good. Then what will be the new order? And then you say, well, the left number, the left matrix, gives me the left number. So now I know that the number of rows from my new matrix will be 3. And the right matrix will give me the right number. So I know now that it will have 2 columns. So my new matrix will look like this: 3 rows and 2 columns. So this is what you will get. Okay. So now you should know when you're allowed to multiply matrix, when the numbers on the inside are the same, and what the order of that new matrix will be. So then I think you're ready for some real examples. Okay. So I now switch to the next slide. And if I'm too fast, just say it, and then I can just give you some time to copy it. If I'm too fast or something, just let me know that. That's the only downside of Zoom, right? Normally, if we are in the classroom, like in the real course, I can just see if you're still writing, but now I don't have a clue, right? Okay. Okay, let's do 2 times 3, and B is 3 times 2. And it will be 1, 0, 1, 2, 3, 1. 1, 0, 1, 2, 2, 1. Something like this. I on purpose take low numbers so that we don't need a calculator. So the first thing you want to check here is, are we allowed to multiply them? And the answer is yes, because those two numbers are the same. Then you look, what is the new order? Well, this number gives this number, and this number gives me this number. So I get a 2 times 2 matrix out of this. Okay, that's good to know. Now I want to know which numbers are going to come on those spots. And this is how you will multiply. You multiply the row of the left matrix with the column of the right matrix. That is how you are going to multiply the row of the left matrix with the column of the right matrix. You start left and you start up. And I will show you what I mean with that. So to find the correct numbers, to get the element from row 1 and column 1, I use row 1 and column 1. So to get element of row 1, column 1, I use the row 1 and column 1. And I start left and I start up. So I do 1 times 1, which is 1, plus 0 times 1, then it remains 1. So I have 1. And then 1 plus 1 times 2 is 1 plus 2. So my first element will be 3. Does that make sense to you guys? Okay. Then to get, for example, this element, yes, I can definitely explain it once more. So to get the element from row 1 and column 1, I take row 1 and column 1. And then I do 1 times 1 plus 0 times 1 plus 1 times 2. You see that? So you start left and you start up. And that gives me the 3. So again, 1 times 1 plus 0 times 1 plus 1 times 2 is 3. Yes, very good. Okay. Then, now to get this element, remember this element is in row 2, column 1. So I take row 2, column 1. And remember, I start left and I start up. So calculate with me. 2 times 1 is 2, plus 3 times 1, which is 3, plus 1 times 2, which is 2. And then if I take this together, I get a 7 here. You see that? Yes, very good. Okay, let's do another one. And eventually it will become really natural for you. So this one is row 1, column 2. So row 1, column 2. So I do 1 times 0, which is 0, plus 0 times 2, which is also 0, plus 1 times 1, which is 1. So this one is a 1. Then the last one. This is row 2, column 2. So I use row 2, column 2. 2 times 0 is 0. 3 times 2 is 6. And then 1 times 1 is 1. And if I add this together, I get a 7 here. And that's exactly what you had in the chat. Very good. So that's how you can multiply matrices with each other. Okay. So let's do another example, and then I will let you guys do it for yourself. Let's say that we have the following. C is a 3 times 2. And I actually already used the letter C. Let me take a different letter. let me use D. And then here we have 2 times 3. And then it will look like this. 1, 0, 2, 1. Let's make it a 4 and a 1 here. And then times 1, 2, 0, 0, 1, 3. Okay. So I will give you guys some time to do it, but I just want to help you guys track. You first have to see that you are allowed to multiply them, right? Because those two numbers are the same. And then you have to see that the left matrix gives the left number and the right matrix gives the right number. So you will get a 3 times 3 matrix out of this. So take some time for yourself to become fluent. And I eventually will just write down some numbers. And if you don't know how to get a particular number, just let me know. Then you, for example, can say, Mark, how did you get the number in row 2, column 3, for example? By the way, I intend to give you guys a small break at 2:15. So at 2:15, you will have a small break to get something to eat and drink, or to just go to the bathroom. So at 2:15 with a small break. So 20 more minutes. I got some water, and then I will give you the solution. So this row with this row gives me the value 1. Yes, so you want matrix C, and then the 2, 1. So row 2, column 1, this element, Monica, is that the element you want to have some explanation about? Let me check. So that's this row times this column. So 2 times 1 is 2, 3 times 1 is 3, and 1 times 2 is 2. So that gives me 7, right? Ah, yes. No worries. No worries. Okay. So let me do some calculations. 2, 0. This one times this one is 2. This one times this one is 5. And let me know if I make a mistake, because I also sometimes make a mistake. 4. And then a 9. And this one times this one is a 3. So I think this should be the solution. Did you guys have that? Or at least a part of it. If you're not that fluent yet. What did you then have, Mickey? Did you have something different? Yeah, of course. So do you want me to just take some time to go through it? Or just take some time, and then now I will explain it. Okay, no worries, Mickey. I will show enough examples so that everybody sees the pattern. So you figured out that it is a 3 by 3 matrix, right? Okay. So you take to get the element from row 1, column 1, you take row 1 and column 1. And remember, you start left and you start up, right? So I take the number on the left times 1, which is 1, right? And then 0 times 0 is just 0. So the number that I get here is just a 1. You see that? Then, to get the element from row 1, column 2, I use row 1, column 2. I start left and I start up. So 1 times 2 is 2, and 0 times 1 is 0. So this will give me 2. Okay. Then I want to have the element in row 1, column 3. So I use row 1, column 3. I start left and I start up. And if I multiply 1 times 0, I get 0. And 0 times 3 gives me 0 as well. So this number will be 0. Okay. Let's do some more. Here I want to have the element in row 2, column 1. So I of course use row 2, column 1. I start left and I start up. So 2 times 1 is 2, and 1 times 0 is 0. So I get a 2 here. And then, of course, eventually it will become really natural. So we now want to have the element from row 2, column 2. So I use row 2, column 2. I start left, I start up. So 2 times 2 is 4. And 1 times 1 is 1. So that gives me a 5. And then I continue. Row 2, column 3. 2 times 0 is 0. 1 times 3 is 3. So I only have a 3. And then row 2 times column 1. 4 times 1 is 4. Plus 1 times 0 is 0. And 4 plus 0 is 4. And then row 3 times column 2. 4 times 2 is 8. Plus 1 times 1 is 9. So I get a 9 here. And then eventually, there's this, gives me a 3. And then you have the whole matrix. Okay? Yes. So the question is, can you give us another question about this so you can practice it once more? Of course. Here's a nice one. A is 1, 2, 0, 1. And the question is, what is a squared? Well, if you want to square it, it will not be 1, 4, 0, 1. So you cannot simply square the numbers individually. No, 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 no. What you have to do is you have to do a times a. That's basically the a squared, right? Okay. So you first check, am I allowed to square it? And you will always see, yes, you're always allowed to. You're always allowed to square a square matrix, because 2 times 2, those two are the same. And then the left matrix gives you the left number, and the right matrix gives you the right matrix. But you're only allowed to square matrices. Okay. And then you write it down like this: 1, 2, 0, 1. 1, 2, 0, 1. So I would just give you guys some time, and then you can figure out what the answer is. And you can say to me in the chat if you're finished, or you can send me the answer. Already see the first answers coming in. So you don't get a number, you get, of course, a matrix out of it, right? So the A squared is just a matrix. So I'm wondering what kind of matrix will you get? Let me see, Anna. 1 times 1 is 2 times 0 is. I think that could be the case. Yeah, so Anna and Boris have the same answer, so I didn't check it yet, but I think you guys both have it correct then. I think I will write down the solution. So we do row times column, right? So the first one gives me 1 times 1 is 1, plus 2 times 0 is 1. Then you get this row times that column. So 1 times 2 is 2, plus 2 times 1 is 2. So it gives me 4. Zero times 1 is 1. 0 times 1 is 0, plus 1 times 0 is 0. So this will just give me 0. And then the last one, 0 times 2 is 0, plus 1 times 1 is 1. So I just get 1. And I think you guys said that in the chat, right? Very good. Okay, so is this one clear for everybody? Just a question. If I have B, which is a 2 times 3, and C, which is a 2 times 3 as well, am I allowed to multiply them? No, right? You're not allowed to multiply. So you write down impossible. But what if I transpose matrix B? What will be the order then if you transpose B? What is the transpose of B? Yes, very good. 3 times 2. So the order switches, right, if you transpose it. And am I now allowed to multiply them? Yes, right. And what will be the new order? It will be, sorry, new order will be 3 times 3. Very good. So the left number gives the left matrix gives the left number, and the right matrix gives the right number. Very good. Okay. So we will top it up with some exam questions. And then we have a break. So I think if I remember correctly, we now have 2 exam questions. And then we have a break. You can simply put the answer in the chat if you have it. Or you see some correct answers coming in. Very good, Anna. Very good, Richard. No, the answer is not impossible. Chanel also has the correct answer. No, it's not 3 times 4. I think you made a mistake somewhere. Let me tell the answer. Okay, so A is a 4 times 3, right? But if we transpose A, then the order will flip. So now the order will be 3 times 4. And B also is a 4 times 3. So first you check if you're allowed to multiply it. And that's only allowed if the numbers on the inside are the same. So they are the same and therefore we are allowed to multiply them. And then the left matrix gives the number on the left. In the right matrix gives the number on the right. And now you know that this is the answer. Are there any questions about this one? Any questions? No questions? All clear? Okay. Then one more question. So here you have to square matrix R. But remember, you don't have to calculate the whole matrix. They only want to have this element. So let's see if you are also know how to only find this element. Okay, so I would just give you guys a few minutes and you can send the answer in via the chat to me. No, it's not 0.
to count down. What's this word coming to?
Bro, mute yourself, man.
I've muted him. Thank you. Doesn't matter. Think, if I remember correctly, that that's the correct answer, Anna. I don't know about the rest, but maybe I can sketch it a bit just to help you guys. So remember, this 3 is the row, and this 1 is the column, right? So we want to have 2, 0, minus 3, 1, 1, 4, 7, negative 2, 0, times 2, 0, negative 3, 1, 1, 4, 7, minus 2, 0. Okay. So first of all, we are allowed to square it because it's a square matrix. So we already know that it will have 3 elements. And we want to have the element from row 3 and then column 1. So we want to have this element here. This is the element we want to know. And to get the element from row 3, we use row 3. And since it is in column 1, I use column 1. And I start left and I start up. So I do 7 times 2, which is 14. And then negative 2 times 1 is minus 2. And then 0 times 7 is plus 0. Do you guys agree with this? And then this will give me 12. So this element here, the row 3 column 1 element, is 12. That's the final answer, 12. Are there any questions about this one? Or do you want me to explain it some more? Or is it all clear? I'm actually wondering how you guys did get the 7. Yeah, I don't know how you arrived at that answer, but it is really 12. Okay.
Wait,
All clear?
can you explain it one more time?
Yeah, of course, Max. So you understand that we want to have this element, right?
Yeah.
Okay. And because it's in the 3rd row, I use the 3rd row. And because it's in the 1st column, I use this 1st column, right? And I always start left and I start up. So 7 times the 2 is 14. Maybe I can actually use a different pen. So 7 times 2 gives me 14. Negative 2 times the 1 gives me negative 2. And then 0 times 7 gives me 0. You agree with that?
Yeah, I get it. I get it.
Very good.
Yeah. Right, thank you.
You're welcome. Is this clear for everybody? Or are there any questions? Can I clarify anything? Can I clarify anything? All clear? No questions? Then let's have a small break. So here's the solution. We have a small break and we will continue at 15:30. So I'll see you then, guys. We will almost continue. So just one more minute. Okay, or just send a message in the WhatsApp group that we continue. Okay. So what you will see, what is the most important property, is that A times B is not the same as B times A, and I will show you why. So maybe you can remember that if we first had A, which is a 2x3 matrix, and B, a 3x2 matrix, then AB will have order 2 times 2, right? But if I would switch those two up, so if I would do B times A instead of A times B, then you would get this. 2 times 3. So now the B times A is a completely different matrix than the A times B, because this will have order 3 times 3. While if I do A times B, you get 2 times 2. So what I'm trying to say is the following. The order matters with multiplication. If I do A times B, I get something completely different than B times A. So the order does matter here with matrices. Remember that. Okay. And that will is pretty important, because the whole algebra rules that you learned on high school changes when you are going to apply it for matrices. Here are some other interesting things. This one is not that important. It is important, but I want to focus on this one here. What you are seeing here is the identity matrix. And the identity matrix is the following. You have a 1, a 0, and a 0 and a 1 here. So you have all ones in your diagonal and zeros otherwise. So for example, if you have the 3x3 identity matrix, then it looks like this: 1, 0, 0, 0, 1, 0, 0, 0, 1. So again, you have ones in the diagonal and zeros otherwise. That's how it works with an identity matrix. And you can basically see the identity matrix as the one from linear algebra. For example, if you multiply a number times 1, you just get that same number, right? And the same holds for matrices. If you multiply a matrix with the identity matrix, you just get that same number, that same matrix, just like here. And I will show you that with an example. So if I multiply those two matrices, I get this row times this column. So I get 1 times 1 plus 2 times 0 is 1, right? If I do this row times this column, I get 1 times 0 plus 2 times 1. So that also gives me 2, right? Then this row times this column, 3 times 1 plus 4 times 0. And that gives me a 3, right? And then this row times this column gives me a 4. So that's pretty interesting, right? So if you multiply a matrix with the identity matrix, you exactly end up with the same matrix. You see that? And that's pretty interesting. if you change it, the identity matrix times A, you would end up with the same result. I times A is also A. So that's the identity matrix, and a really interesting property of the identity matrix. A times I is A. Okay. Then the next property. This one you can try out yourself. Then this interesting property. So what you're seeing here is the inverse of a matrix. And what happens, I will show you later how to find the inverse. You can use Gaussian elimination, but I also have a really nice trick to find it. But for now, you can remember that if you have a matrix times its inverse, you get the identity matrix. And here I just have some example. So just assume that this is the inverse matrix of A. I will show you later how to find it. You can now assume that this is just the inverse. And what you will see is that if I multiply the original matrix with the inverse matrix, I get the identity matrix. It is just like 2 times a half is 1, right? So 2 times the inverse is 1. The same holds here for matrices. So I get this row times this column. So I get 1 times -2, which is -2. And then I get 2 times 1.5, which is 3, right? And this together gives me this 1 here. Then I do this row times this column. So I get 1 times 1 is 1. 2 times a -half is a -1. And this together is this 0 here. So you can do that for all the numbers, and you will see that you end up with the identity matrix. Let's do one more, and then I think you believe me. So this row times this column gives me 3 times -2, which is -6. And 4 times 1.5 is 4 times 1.5. I have to think about that. 2 times 3, so 6. Sorry, plus 6. So -6 plus 6 is 0. And I think you already believe me that this will become a 1, right? So if you multiply a matrix with the inverse matrix, you get the identity matrix. So by now, you should have the following. We learned that A times B is not the same as B times A. So the order matters. You learned what an identity matrix is. You now know that A times the identity matrix is just A. And you now know that the A times the inverse matrix will be the identity matrix. That's the three things we just learned after the break. Okay. Then I'm going to show you an interesting topic. This is maybe the most difficult topic I'm going to discuss with you guys today. Oh, I see that you raised your hand, Max. Do you want to ask a question?
Yeah, please. So the last slide, how do you get like the final like 1 0 0 1
Okay.
thing?
So how do I get this matrix here?
Yeah, because you wrote some numbers below, right? Like the 3 times 3 2 and stuff like that. But then how do you get 1 and 0?
Okay.
That type.
So maybe we can do it together. So I get this row times this column to get this element, right? 1 times -2 is -2. And then 2 times 1.5 is 3, right? 2 times 1.5 is 3. And this gives me the 1 here. So you understand how I
get it. Yeah, then the other ones are the same, I guess.
Yeah, exactly.
All right.
And
Okay.
you will see that you end up with this one. Okay.
Thank you.
You're welcome. So what am I going to prepare you for? So this will be a difficult topic. What I'm going to prepare you for are those type of exam questions. So you get a particular equation, and you can recognize that we are talking about matrices because we have both capital letters. So we have bold capital letters. So we're talking about matrices here. And you want to solve it for x. So you want to get x is something. But the problem is that because we're using matrices, the algebra rules you learned on high school don't apply anymore. So you have to use the linear algebra rules. So not the algebra you learned on high school, but linear algebra. And you have never seen it before, I assume. I don't think if you studied in the Netherlands, you at least already are familiar with the matrices. So you have to learn different algebra rules than you normally are. Because, for example, division is not defined for matrices. You cannot divide a matrix by another matrix, for example. So I'm going to show you how to tackle those axiom questions. So I'm first going to give you the rules. And then I have 3 axiom questions that we can do together. So this one will be used as an example. Then we will do this one together. And then I will let you guys do this really hard one on your own. And then afterwards, I will provide you guys an explanation. Okay, so let's start with the rules. So the first rules we already discussed. It's an important rule to remember that order matters. So A times B is not the same as B times A. Maybe I can go to the whiteboard to give you guys a really nice overview of all the rules. So let me write it down. Linear algebra rules. So if you're working with matrices, I will give you now a really nice overview to pay attention. So the first one is order matters. Remember that A times B is not the same as B times A. Those are the linear algebra rules. The other one was that if you do A times the identity matrix, you get you get A, sorry. And if you switch it up, so I times A, that will also just give you A. Okay, that's the first rule, and this is the second rule. The third rule we already saw, that is if you multiply it with the inverse matrix, you get the identity matrix. And also if you switch it up, so you take the inverse matrix first, you also end up with the identity matrix. And now I will start by adding some extra rules. So one extra rule that you can remember is that if you have an X, a matrix A, for example, and it is transposed, and you want to get rid of this transpose, you can transpose it again, and then it will cancel out. So let me show you with an example. If I have, for example, A is 1, 2, 3, 4, 5, 6, which is a 2 times 3 matrix. If I transpose it, the first row becomes my first column. Remember, that was what the transpose was. And my second row becomes my second column. So that's what we have here. And what I'm going to show you is that if I transpose it again, so I transpose the transposed matrix, I will end up with the original matrix. You can see. So 1, 4 will be my first column. 2, 5 will be my second column. And 3, 6 will be the third column. And now you will see that if you transpose a matrix twice, you end up with the same matrix. So those two matrices are the same. So remember, if you want to get rid of a transposition, you can transpose it again, and then it's gone. That's basically what you can remember from this. So if you want to get rid of the prime, you can transpose it again, and it's gone. Then some other rules that you need to remember. If you have A plus B, A transpose it, it is the same as you first transpose it, and then after you transpose it, add it together. So you can add it together, then transpose, or you can first transpose and then add together. It doesn't matter. That's basically what this rule tells you. And then here, this one is pretty nice. A times B. So I first multiply, then transpose. I can also first transpose, but then I have to change the order. So instead of A times B, I will have B times A. You see that? And then I transpose things individually. So B transpose times A transpose. So you can basically remember, if you have this, you can change the order and then transpose each matrix individually. So for example, if you have A times B times C, and you transpose it, what will happen is that you can flip the order. So I don't have ABC, but I get CBA. And then I transpose each matrix individually. That's basically what this rule tells you. Okay. And then you have this rule. That's pretty important. That is that it doesn't matter if you first take the inverse and then transpose it, or that you first transpose it and then take the inverse. That's basically what this rule tells you. It will give you the same answer. And remember, a transpose is something completely different than the inverse of a matrix, right? And I will show you later how to find the inverse of a matrix. But, okay. Okay. So did you guys wrote down those rules? Then I will give you some examples, some really easy examples, so that you get a feeling for what we're looking for. Okay. So here is the example I'm going to show you. So what you can, for example, have is that you have x times y is q. And you want to solve it for x. So remember, we want to know x is something. That's what we want to know. Solve it for x. So what you can do is you can first get rid of this y. But you have to really be careful here. What would be wrong is if you say q divided by y. That would be wrong because you cannot divide matrices by each other. That doesn't exist. So that's not the answer. We are not working with normal algebra. Remember, we are working with matrix algebra. So instead, I can do the following. So this is the strategy. This is an important part. You put the inverse matrix behind the y. And if you do that on the left side, you also need to do that on the right side. So you put the inverse matrix behind it. And then you hopefully remember the rule that the y times the inverse becomes the identity matrix. And what happens if you multiply a matrix with the identity matrix? You just end up with the matrix. So here you have your answer. So what is the insight from this example, this first example? The insight from this example is that if you want to get rid of a y, you put simply the inverse matrix behind it, because then it will become the I. And if you multiply I with the matrix, you just end up with the matrix. So remember, if you want to get rid of the y, you simply put the inverse of y behind it. Okay, that's example 1. Was that one clear? Or are there any questions about this one? Then here I will show you another example. What if I have the following? Z times x is y. Now I want to get rid of this set, right? Because I want to solve it for x. But here's the thing. Remember that order does matter. So I copy this here. And the question is, I want to get rid of the set. I think there are 3 things you could do. you want to do something with the inverse of Z, right? We saw in the previous example that if you want to get rid of a matrix, you multiply it by the inverse of it, right? What I want to stretch here is that it is really important to, in this case, put the inverse of Z on the left side. So you have to place it next to it to be able to let it disappear. So for example, if the matrix that we want to have gone is on the right side, I place the inverse on the right side. But here, the matrix that I want to have gone is on the left side. So I place the inverse on the left side. Do you guys see that? Okay. And if you're doing that here, if you're placing the inverse in front of it, also on the right side, you should place it in front of it. For example, this is not the same as when you would do y times the inverse of z. Do you see that? So the order does matter. This is correct, and this would be wrong. It is really important to, if you place it here on the left, you also place it here on the left. You see that? That's very important. Okay. And then we can just simply finish it up. Sorry, popped in my screen. So now we can simply finish it up. This here becomes the identity matrix, right? This remains the same. And the identity matrix times x becomes x. So x is the inverse of z times y. That's the solution for x here. Do you guys see that? So remember, if you want to have a matrix gone, simply put the inverse of the matrix in front of it or behind it. So is it clear why we place the matrix here on the left side? And in the previous example, why we place it on the right side? Why that is so important? Is that clear for you guys? Yes? Are there any questions so far before I go to the exam questions? No questions? Okay. So here I'm going to do an exam question, and I will ask one of you guys to maybe help me. For example, Monica, would you maybe like to help me?
Sure.
Okay. So we start with this equation here. Y, x prime, and then y, q, y. My question to you guys, to you, Monica, is how can I get rid of this y?
You add the prime, right?
I add the inverse matrix before it, right?
Yeah.
And what should I do then on the right side?
Add it to on the left.
Yes, on the left. So does it matter if I place the one here or if I place it on the right side? Does it matter?
Yeah, it does matter, right?
Yes, it does matter. If you place it here in front, you should also place it here in front. So indeed, so this is the first step. Very good. Then what happens with those two here?
It becomes the I.
It becomes the I. And
No.
those two, sorry,
Yeah.
as well. And if I have I times x, that will be?
X1.
Yes, x prime, yes.
Yeah, sorry.
And then this will be, no worries. And this will be
QY.
Very good. This is not the final answer because we still have a prime here and I want to get rid of that prime. What did you learn to how to get rid of that prime?
I do it to the power of prime.
You transpose it again. You can basically do power of prime again. So you do it again. So you get x prime primed. And then I also have to do that on the right side, q times y prime. So then we have it like this here, right? And then what happens here is that I get
X. Like the normal.
x. And let's see if you still remember the rules I wrote down. What will happen with this here?
I don't remember.
Maybe I can give you the rule. It was AB prime will be BA prime prime, remember?
Oh
So,
yeah.
the-
Okay.
so here I get,
Q prime and Y prime.
yeah, but
Oh, Y prime,
remember
Q
order matters. So
Yeah,
Y
sorry.
prime, Q prime. The order does matter with matrices. Very good, Monica. This is the final answer. So I would just mark some steps. So I would just write down step 1. So rule 1, rule 2, rule 3, 4, 5, 6. And then I want to give you guys the chance to ask your questions. So you can just say, Mark, how did you go from step 3 to 4? What is the rule you apply there? How did you go from step 5 to 6? I don't see what you're doing there. So feel free to ask me the questions. Then I can clear it up. And thank you, Monica. Are there any questions? Or is it all clear? No questions? Okay. Then I will just erase this one here. So just to give you guys some perspective. Oh, sorry, from step 3 to step 4. You want to know what happens from step 3 to step 4? Narita? Okay. So the rule that I applied was from step 3 to step 4 is that if you multiply the identity matrix with a matrix, you just get A. So it is basically like 1 times 4 will just give me 4, right? That's the rule I applied there. So I times X would just be X, you see that? I times Q would just be Q. That's the rule I applied there. Okay, any other questions? No other questions? Okay. Oh yes, from 4 to 5. What did we do at 4 to 5? So from 4 to 5, what we did there was that we could say, all right, if you have X prime, you can prime it again to get X. So here we had a prime and we want to get rid of it. So I prime it again to get X, you see that? So X prime, I prime it again, and then it's gone. That's the rule. If you transpose a matrix twice, you get the original matrix. And if you want, I can show you an example. Okay, then from 5 to 6. So yeah, like I said, if you prime the X again, those two will cancel out. So I hope you understand the left side. Else I can give you an example, just let me know. And then on the right side, from 5 to 6, I apply this rule, AB prime will be, you change the order and you prime each matrix individually. So here I have QY, I change the order, so it will become YQ, and then I prime each matrix individually. That's what I did at this step. Is that clear? Great. Any more questions? It looks like on the second step, you outer prime in the Q. Yeah, that's a mistake. I don't know what happened there. So thank you for pointing that out. Yeah, I'm sorry for that. I think I just made a mistake or something. No more questions then? Okay, so this is a difficult topic. And also, like I said, you didn't study this yet. So you will learn it in the upcoming week. And then I hope you already have a foundation when you're watching the lecture by looking at this session. Okay. And I think this is maybe the most difficult topic of today. Then, here's another excellent question. I think it is just a bit too difficult. So I'm not sure if I should give you the time to do it first yourself. Maybe I can just point somebody out to help me with it. And then I think that works. Carina, would you maybe like to help me? Would you like to help me, Carina? No. Then I can also ask somebody else. So, okay. Maxime, would you like to help me with this question? I will guide you.
Yeah, I mean, I can try. I don't know if I can do it, but I can try.
Yeah, no worries. We're all here to learn, right? So I don't expect that you know it perfectly already. So I will just guide you. So we have a times x minus I is b prime, right?
Yeah.
And maybe you remember it, but I think the addition and subtraction of matrices, that was not different from normal algebra. Do you remember that?
Yeah, so you can add the I.
Yes. Yes, I can add the I to both sides. And then I get AX is B prime plus I, right? So nothing strange with the I. That works just the same as normal algebra, right?
Yeah.
Okay. How can I get rid of this A here?
By multiplying it by the inverse, right?
And is it important that I put it in front of it? Or am
Yeah.
I also allowed to put it behind? Sorry?
In front.
In front, right? That's really important because the order does matter with matrices. And then here on the left side, on the right side, I also have to add it, right? And what you will do here, you haven't seen this before, but you can just do B plus I. You can basically treat the B plus I like it's one matrix. So you get this, right? Does it make sense?
Yeah.
And then A minus 1 times A will become
The I, right? Isn't it just I?
and that will just become. And then here, I will just leave it for a second. Right, sorry, I see. But that gets rid of the B's prime. I don't know what you mean with that gets rid with the B's prime. Could you clarify that comment, Tristan? I don't understand what you're meaning there. Could you explain what you mean by that? Yeah, from step 2 to 3. Oh, sorry. No, sorry. Yeah, I forgot to copy this B prime. Thank you. That's what you're meaning. Sorry. So I forgot to copy the B prime. Thank you for pointing that out. So here, everyone will color it red. Here, you should add a prime. I forgot to write it down. Thank you, Tristan. Okay. And then I times X would just be X. And here I don't see now my answer in the multiple choice model. So maybe I can work out the brackets. So then I get A minus 1 times B prime. And what do I also get, Maxime?
Isn't it just I times A minus 1?
Yes, and that would just be?
Just A to the minus 1?
Yes, very good. So A minus 1 times I would just be A minus 1. So which one of the solutions it is?
C?
Yes, it is C, right? So this C is the correct answer. Very good, Maxime. So again, I will just put some numbers here. 1, 2, 3, 4, 5. And then you can ask me a question. Does anyone have a question or is it all clear? So Richard, you ask, how did you go from line 4 to 5? Well, on the left side, I apply the rule that if I have I times a matrix, I just get A, right? It's just like 1 times 4 is 4, right? So that's what happened on the left side from 4 to 5. Maybe I can add an extra step on the here. What I can do is I can maybe write it down like this. A minus 1 times b prime becomes a minus 1 times b prime. And a minus 1 times I becomes a minus 1 times I. So maybe now you understand this step better. And then from step 4 to 5, you get that those times each other will simply be I minus 1. Does that make sense? Yeah. Does that make sense, Richard? So this thing here becomes this thing here. That's basically what happens in step 4 to 5. You're welcome. Any other questions? No other questions? All right, then we move on to a really difficult one. So here is a really difficult one. I would just give you some time to try it, but I promise you it is pretty difficult. So don't feel bad if you are not able to do it. While you're trying to figure out the solution, I will sometimes add an extra line. So just so that you can check yourself. But like I said, this is a really difficult topic. So I will just start by writing down some lines, just so that you can see if you're on the right track. This is what you should do as your first step. You should just get the B to the other side. See if you did that. Okay, we'll add some extra lines. Think that's almost correct. I'm not sure again what the answer was because it, yeah, I just have to do all the steps before I know it. But we will see if that's the correct answer. Okay, so the other is that maybe I can from here ask somebody of you, because if I explain it, it all might look easy, but if you have to do it yourself, it might be different. So I would just ask somebody of you. Maybe boy, asked Jason wants to help me. Do you want to help me, Jason? No, maybe Tristan then. Would you like to help me, Tristan? Also no reaction.
Hello?
Oh,
Hello?
Tristan, would you like to help me with this question?
Sure.
Okay.
I
How do I get, yeah?
I think what
How
you
do I,
do there is you add to the right an A inverse.
yes, very good.
Oh, good. Okay.
So we
And you
add
say
the
it was,
inverse of A. And then on the right side,
you also add an inverse to the A
yes,
on
but
the right.
remember you should use brackets then,
Yeah.
right? Because basically you can see this matrix like one big matrix, and that whole matrix is times A minus 1. That's what happens here. Okay. And what happens then, Tristan?
So
What
this
happens
gives
with this?
this gives us x prime I.
Very good.
And I wasn't sure how to
And
expand this out, but I think it's I
yeah,
A inverse plus B
it is some
A
inconsistency relative with the previous one, but here you don't want to
expand.
expand it. So we just leave it as it is. You see
Yeah,
that?
that's what I did because I wasn't sure how to expand it. So then
Yes.
this gives us x prime is the same.
Mhm. And then
So
how
then
can
what
I
I
get rid
did,
of this? Yeah.
I primed that x prime.
Yes, very good.
So that gives us
And
I
then
plus B A inverse prime.
yes. I completely agree with that. And you will see that this is the most difficult axiom question. What will the left part be?
Just x.
Just x. And here,
Well,
this
yeah, how
is
do you finish?
a
I
thing
don't
that
know
a
how to
lot of
expand
students find
this.
difficult. Sorry?
I don't know how to expand this bit, so that's why I stopped.
Yes, no worries. What you have to do for the right side is you have to use this rule. A times B prime becomes B prime times A prime. You agree with that, Tristan?
Yeah.
So
Oh,
this thing on the left, sorry, this thing on the right now comes back at the left. So we have -1 and then A prime. So this is what the right matrix will now become on the left. And the matrix on the left now becomes on the right with an individual prime. You see that?
Yep.
Okay. Then maybe you could, this one is optional that I'm now going to show you. Oh, sorry, I see something in the chat. Why does it switch places? Yeah, that's just what you need. You can try it out with some small matrix like 1, 2, 3, 4, something like that. Just an easy matrix. You can just check this rule for yourself, and it's really the case that this is true. If you want, I can do after this an example to prove this to you. Just help to remind me that. Yes, that's because of the rule. And the rule really is true. I can show that the rule is true with an example. But for now, you can just assume this. So therefore, we switch places. And then, Tristan, maybe you remember this one. If we have a with the power of -1 primed, we could say it is a primed and then?
Oh, it's A prime -1.
Yes, exactly.
So
So
the
the
swap.
left side, but that was optional according to the answer model. You could write it down like this.
Oh, okay.
And do you also remember? Oh, I see something in the chat again. Okay, you accepted me. Okay, that's fine.
Sorry, there was an accident. Those emojis.
Oh, no worries, Max. It's all fine. And then I plus b prime. If I have that
I
one,
prime plus b prime.
yes, very good. So I will write down the rule. Maybe you recognize it. A prime plus b prime. So that's the rule we can apply here. So you get I primed plus b primed. Okay. You think you are almost there then, right? Because you
Yes.
already did so much. There's one thing, and this one is really tricky, and it will make sense if I explain it. You will see. Tristan, what is
Yep.
the I? The I is 1001, right?
Yes.
What is the I prime? So the first row becomes my first column, right?
Yeah. Oh,
And
just
then the second row,
huh.
what do you see?
Oh, just I.
Yeah. So what kind of matrix is the identity matrix? It's a
Symmetrical.
symmetrical matrix. Very good. So we can just leave out this prime here. So I can just write it down like a prime minus 1. And then instead of I prime, I can simply write down I, because it's a symmetrical matrix. And there you have your final answer. A lot of steps, right? Difficult axiom question. Okay. Thank you very much, Tristan.
Yep.
Okay. Are there any questions from you guys? Are there any questions? So you can just say, Mark, how did you go from step 3 to 4, or from step 4 to 5, or whatever? Which rule did you apply? No questions? Here's the question. If you have a b prime, you do b prime a prime, and if it's plus, you don't switch. I think you want to put a bracket there in your question. So let me rephrase your question. So I think your question is, Anna. Question from Anna. Yes, just for the students. So if it's a like this, and the answer to that question is yes. If it's plus, you don't have to switch, because with multiplication of matrices, the order does matter, right? A times B is not the same as B times A. But with addition, the order doesn't matter. So I can just do, for example, here, my final answer could be I plus B prime, but I could also do B prime plus I prime, because with addition, the order doesn't matter. But with multiplication, it does. Does that answer your question, Anna? So in your final answer, you could also have switched those two. That would be fine. Okay. Any other questions? No other questions?
Yes, I
Okay.
have a question.
Okay. I think I don't
I
hear you
do.
very well. I
At step
think
5, what would happen if, sorry, my, okay,
it seems
I'll
a bit like
put
your
it in chat.
internet connection is not that good, Shnelva.
Yeah, my internet connection is not that good.
Oh, okay. So you also probably have a hard time to hear me, or do you hear me clearly?
Not really. I will put it in the chat.
Okay, okay. That's also fine. So just wait. Yeah, that's the good thing that we will do the
Can
actual
you hear me
course at
now
the time.
better?
Yeah, now I hear you better. I hear you perfectly. So if you want, you can also use your microphone then, whatever you prefer. So you're now typing, right? Or do you want to try your answer with your microphone?
Yes. Can you hear me better now?
Yeah, I hear you perfectly.
Okay,
Do you also
so
hear me?
yes, I can hear you. Okay, at step 5, what would happen if I would just calculate on a to the power -1 with I plus b? Just do it like that.
So at step 6, you mean? So here,
5.
here you do.
Yes.
Sorry, could you repeat your question?
If I would
Here
just
you do.
calculate a to the power -1 with I and plus b.
Like this.
Yeah, but inside of the bracket, I just,
And then inside of the bracket you?
yeah.
Okay, okay. Oh, I see what you mean. So you say, do you mean this?
Yes.
That actually would be, I think the step is mathematically correct. So you are allowed to do that. If that's
Yes.
like,
But then
yeah.
how will my answer be at the end? Because
Then here you get a minus 1 plus b a minus 1 prime. You agree with that?
yes.
Oh, I didn't copy everything. So let me shrink this a bit. And then it would be like, you get the a minus 1 prime plus ba minus 1 prime. And that would be the same as this thing here would be a prime minus 1, right? The left side.
Uh-huh.
And then the right side would be a minus 1. And then a prime. And then b prime. Do you agree with this?
Yes. Okay.
And then if you want, you can take the a prime out. You can write it down like this: a prime minus 1 plus. So I here switch the -1 and the prime. So
Yeah.
here I get -1. You also agree with this?
Yes.
And then if you want, you can take out the a prime -1 from both sides. And then you get I plus b prime. And that's also the final answer.
Oh, okay. I
So
made a
if you would have
mistake.
done that, you would be also fine. That's
Yeah,
basically
I
the
made a
point.
mistake somewhere. That's why my answer wasn't the same. Okay, thank you. Thank
Yes.
you.
Yeah. So as long as you apply the rules, nothing can go wrong, basically.
Okay, thank you.
Okay. Any other question? No other question? No? All right. Then I see that we are almost at the time. So I don't have the time to do the Gaussian elimination part. I'm sorry for that, but I think we already discussed a lot today and a lot of excellent questions. But I will just give you a really nice trick before we call it a day. So with Gaussian elimination, the idea is that you can find the inverse matrix. So just to move a bit forward in my summary, you can just check the slides out. I have sent it to you in the WhatsApp group. You can use Gaussian elimination to find the inverse matrix. So if this is your original matrix, then with Gaussian elimination next week, you will learn how to find the inverse matrix. But the Gaussian elimination is a lot of work. You have to know it for the exam, but it is a lot of work. So I want to finish this session today with a really nice trick so that you don't always have to use Gaussian elimination. And the trick will go as follows. And I will just show it to you on the whiteboard. So here, trick to find the inverse matrix. Okay, so here it is, and this will be the last thing I'm going to discuss, and then I will give the study manager the word because he wants to tell something to you guys. So here it is. So A is, for example, 1, 2, 3, 4, and let's call those elements A, B, C, D. Okay. According to this trick I'm going to show you, you can find the inverse by doing 1 divided by A times D minus B times C. Believe me, this will be way easier than Gaussian elimination to find the inverse of the matrix. So A times D minus B times C. So that's the first thing you do. Secondly, you switch up the A and the D. So you do D and A. And lastly and thirdly, you do minus B and minus C. The first time you see this, you think, whoa, this looks a bit harder, right? But you will see that it is really easy, way easier than Gaussian elimination. So you now do 1 divided by 1 times 4 minus 2 times 3 you switch the 1 and the 4, that's the second thing you do. And then you make the 2 and the 3 negative. And what you will get is the following. This is 4 minus 6. 4 minus 6 is negative 2. And then you basically get minus a half times 4. So minus a half times 4, that will be minus 2, right? And minus a half times negative 2 is a positive 1. And minus a half times minus 3 is 1.5. And a negative half times 1 is minus a half. And now you have found the inverse matrix with a really easy trick. So remember, you do 1 divided by this diagonal times this thing here. That's the denominator. You switch the A and the D, and you make the B and the C negative. Those 3 things. And then you have the inverse formula. Okay, so let's do one more example. Okay, let's do one more example. B is 1, 3, 4, 6. Who wants to help me? Anna, would you like to help me with this one?
Yeah, sure.
So you do 1 times 6, which is 6, right?
Mhm.
Minus 3 times 4.
Yeah.
What do I do with this matrix? I switch the
A and the D.
yes.
So
So
it's
the
6
1 and the
there.
6 there, and a 1 here.
Yeah.
And then make the 3 and the 4.
You make it a minus.
Yes. This is 6, right? minus 12, that will be
Oh,
well,
sorry.
the denominator.
Minus 6.
Minus 6, very good.
Yeah.
And then 6 divided by minus 6 is minus.
Oh,
Oh, sorry, I was one step too far. One step too far. Sorry, I just copied it.
no, it's okay.
And then minus 1 over 6 times 6 is
1.
negative 1.
Negative 1.
And then a negative 1 over 6 times a negative minus 3.
Half.
Positive 1.5. And then this thing times this thing here.
Is 2/3.
Yeah, that's a 2/3. Positive 2/3. And then minus 1 over 6 times 1.
Is minus 1 over 6.
Yes, perfect. And that's how you can find the inverse of a matrix with a really easy trick. And it's believe me, it's way easier than Gaussian elimination. Okay. Thank you, Anna. So I think that's it for today. Then I will now give the word to Levi if there are no questions about this topic. Because I think Levi wants to tell something.
Yes, hello everybody. Mark, can you go to the slide I put in? Yeah, here it is. So hi everyone, my name is Levi. I'm the study manager for IBA for Sophistès. I really hope you like the session today. And you can use the WhatsApp group for any follow-up questions you have about the material. And we're also going to share the link on YouTube, like Mark said, of the recording. So if you want to follow the crash course for the final exam, you can use one of these discount codes that are on the screen. Thank you very much for attending and for participating. And thank you also very much for your time, Mark. I thought it was a really good session.
Thank you, Levi.
Thank you, everybody. So yeah, leave the slide up for a little bit if you want to have a look, but it's also in the slide deck. And we'll share the slide deck again in the group sessions afterwards, together with the YouTube recording if you joined us from the group chat today. All right. Thank you very much for the spot, Mark.
And I'm also here for if anyone has any question, I would just be here. Bye, guys.